Okay, good morning, good afternoon, and good evening to everyone, wherever you are watching this tutorial from. In the previous lesson, we talked about sets of numbers, and of which we emphasized more on the aspect of real numbers, where we said that real numbers is a combination of rational and irrational numbers. Something which is real is basically rational or irrational values. So all those which are all natural numbers, all whole numbers, all integers, all rational numbers, and all irrational numbers are basically real numbers because they are somehow quantifiable. So now, today I just want to narrow it number. This time I want just to talk about the aspect of rational numbers. So yes, we know that rational numbers are a subset of what? Real numbers. And I believe I defined all the sets of numbers last time, but today I'm just trying to talk about rational numbers itself. So what are rational numbers? So just from the definition of rational numbers, we are simply saying that rational numbers, these are numbers. So I'm simply saying rational numbers are numbers that can be expressed in the form a over b, where a and b are basically members of the integer set, and b should never be 0. So in short, if we're trying to describe rational numbers, in this case any numbers that can be expressed in the form of a over b, in short, in simple language, maybe for a grade 1 to understand, we are simply saying those numbers which can be expressed as a fraction a over something. So a and b in this case are coming from the integer set. So remember, integers are basically positive or negative values. So all those values, I can grab my a maybe to be 1, I can grab my b maybe to be 2. I'm going to make a fraction 1 over 2. So that fraction can be expressed in the form of what? That fraction is in the form of what? A over b. But keep in mind that this b should never be 0. So every time we're trying to define rational numbers, we are simply giving an exception. Quite alright, the integer set also includes 0, but in this expression we are simply emphasizing that b should never be 0, because if b is equal to 0, it's going to make this expression to be undefined. That is why I always simply tell people to say that if you punch 0 divided by anything, the answer is 0. So this is what you have to understand. Note, 0 divided by anything, the answer is 0. But anything divided by 0, the answer is undefined. You are unable to define this expression. As long as there is 0 in the denominator, this cannot be defined. That is why even if you were to punch this on your calculator to say 100 divided by 0, 10 divided by 0, 98 divided by 0, the answer on your calculator just becomes something like a math error, because this is undefined. But anything, 0 divided by anything, the answer is basically 0. So every time we're trying to define rational numbers, we are simply saying any number which can be expressed in the form of a over b, then that becomes a rational number. So in this lesson, I'm now going to briefly describe some of the characteristics of what rational numbers have. So once we understand the characteristic of these rational numbers, we'll be able to distinguish them from other values. So for example, if we're trying to talk about rational numbers, we know they are fractions. So let's look at maybe characteristics. How do you spell characteristics? Characteristics of rational numbers. So characteristics of rational numbers. So the first point which you have to understand here is that when it comes to rational numbers, one of the features of rational numbers, we're simply saying these numbers include fractions. Include fractions. That's the first point. So one of the feature in terms we want to list numbers which are rational numbers, we're talking about all fractions. All fractions are basically rational numbers. So these numbers include fractions. For example, e.g., we're talking about something like 1 over 2. 1 over 2 is a fraction. Maybe we're talking about something like 1 over 3. 1 over 3 is a fraction. Maybe I'm talking about something like 2 over 15. 2 over 15 is a fraction. All these are rational numbers, where a is 1, b is 2, where a is 1, b is 3, where a is 2, b is 15. Anything which is in the fraction form is basically a rational number. So that's the first characteristics. And then we have the second characteristic of a rational number, where we are simply saying that numbers that include, or maybe that numbers that have decimals that end. Numbers having decimals that end. That's a simple language you can use. That end. In other language, we are talking about terminating decimals. Terminating decimals. So those decimals that terminate, that have an end, there are those numbers whereby you can never have an end of a decimals, whereby a number is just continuously going 0.12157823. It's continuously moving. Those numbers are not terminating. But here in the characteristics of rational numbers, we're simply saying that rational numbers should have terminating decimals, implying that rational numbers can have, for example, e.g., we're talking about something like a 1.5. The decimal has ended up by 5, 1.5. Or maybe I'm talking about something like a 1.3. The decimal has ended up at 3. We're talking about maybe things like 0.5. The decimal has ended there. And maybe we're talking about the concept of 0.3. The decimal has ended there. So that's a feature of a certain rational number. The last characteristic which you have to understand is that we're talking about numbers that include decimals that repeat. So rational numbers includes decimals that repeat. So that repeat, what do I mean? I'm talking about the concept of, here they have an end, but there will be those numbers whereby when you punch them sometimes on the calculator, you find that the expression whereby we're talking about 0.3333333, the 3 is continuously going. And such expression, I can even write it as 0.3 like a bar on top, indicating that the 3 is continuous. But if I write like 0.3 like this has an end, but this one, the 3 is basically continuous. So an example of a rational number is basically numbers that have decimals that repeat. The decimals are not terminating, but we're simply saying the decimals should be repeating but not terminating. There are those decimals which repeat, but which do not repeat, but they don't terminate. And then, for example, let me just use even this part of the board. For example, I have something like 1.121034617 everything the way this number is moving. I'm having something like, sorry, my handwriting. So 1.1010241687 those cases. So there is a point here. These are decimal numbers. So what I'm saying in the decimal numbers here, they are not ending. They will just be continue moving. So they will just continue be moving. For example, 1018. So it's difficult to express this in the form of A over B. So I'm simply saying that only numbers can be expressed in the form of A over B are the fraction forms. Numbers that can be expressed in the form of A over B as those numbers having decimals that end. So like 1.5, the decimal has ended. 1.3, the decimal has ended. 0.5, the decimal has ended. 0.3, the decimal has ended. These numbers can be expressed in the form of A over B. And then we're also talking about numbers that include the decimals that repeat. So we're talking about decimals that are repeating. These are decimals, but they are not repeating. The values here, which after a point are not repeating, they are changing. 1 0 0 1 8 2 4 1 6. They are basically changing throughout, and they are not ending. But a character of a rational number should include decimal numbers that repeat. So they are repeating at the same time they are not ending. That's what we have. For example, I can have something like 1.13333. So I am seeing a decimal number here repeating. Or others will simply say maybe the concept of 6.15656. 5656 is repeating continuous, just like that. So there must be some decimals which are repeating, unlike in this case where decimals are not repeating. So these are the three characteristics which we'll be able to look at when it comes to rational numbers. So they should be fractions, they can be decimals, but they have an end. They can be decimals, but those decimals should be repeating when they don't have an end. That's the characteristic. So we're now going to solve certain questions according to rational numbers which we are going to have here. So I'm not going to delete everything. We have understood the definition and the characteristic. Now let's now solve some questions. So we are looking at rational numbers. Let's look at an example which we are going to solve according to rational numbers. So this example says express. Let me divide my board on two parts so that we can have some space. My board is very small. So express each of the following. Each of the following in the form of A over B, where A and B are integers and B should not be 0. So we're trying to express the following in the form of A over B. So we'll start with the first one, 0.3 bar. We'll go to the second one, B. We'll look at 0.13 bar. We'll look at C, 6.156 bar. We'll look at D, which is 0.33 bar. Then we'll look at E, which is 0.16 bar. F, this is 2.143 bar, and we have G. G is going to be 3.7 bar. G, then we have H. H will express 1.171717 and so forth. And then we have I, which can be 2.590 bar. So let's look at those questions. This will be my space for working, and then we'll have a question there. I'm sure you guys have pens, you're copying through. So I'm expressing each of the following expression in the form of A over B. So we have to basically look at the characteristic says that numbers which can be expressed in the form of A over B are those numbers which have decimals which have an end, or decimals which are repeating. So when it have a bar like this, automatically I know say this is 0.33333, then it is qualifying to be called a rational number. Then indeed it can be expressed in the form of A over B. 0.133333, the decimal is repeating. This will be qualified to be called a rational number, and it can be expressed in the form of A over B. 6.156, the 56 is continuous repeating because of the bar on top. So it means this will be qualified to be called a rational number, and it can be expressed in the form of A over B. So now, how do we express these in that form? We start with the first one, 0.3 bar. So how do I express that in the form of A over B? First thing is first, let the expression to be any letter of your choice. So this is my expression. So I can say let x be equal to 0.3 bar. And you know that bar, it means it's 333 repeated. So we are now, what are we going to do now here? I'm now going to multiply my x with 10. So why am I trying to multiply my x with 10? I'm trying to move this particular point here to my right side to make sure it reaches one of the repeating values should be. In short, I'm moving my point to the first repeating value on my right. So the only way this point can move to my right direction is by multiplying this x by certain values. So if I was to multiply by 10, this point is going to move once. If I was to multiply by 100, this point is going to move twice. 1 minute. So we are multiplying x by 10 so that we can have the repeating part to move to the left side. So we are simply saying multiply x by 10 so that the repeating part can move to the left side. So if this is x, the only way the repeating part can move to the left side, I'll multiply it by 10. So therefore 10x is going to multiply this once, so the point to move there, it means I'm going to have 3 points. There is another 3. If this point has moved here, there's another, remember there is the 3 continuous. It means I'm going to find another 3 this side. So there will be another 3 here again, but indicating that the 3 is still continuous. So if this is my first equation, which I've related to my x, this becomes my second equation. So when we're simply saying that we are trying to multiply this by 10 so that the repeating side can go to the left side, or maybe the repeating side can move to the left, we are trying to do this so that when we subtract these two equations, remember the end of it, we want to subtract these two equations, so that when we subtract, the repeating part can cancel out. So we're trying to make sure that the repeating sides cancel out. So the only way the repeating sides cancel out, we multiply this by a certain value so that a certain repeating part moves to the left, like this. 3 has moved to the left by multiplying x by 10. So I have first equation and second equation. So what I have in the first equation, after the decimal I have 3 repeating. The second equation again, after the decimal I have a 3 repeating. So that we can have, now say, subtract. What am I going to subtract in this case? I'm going to subtract 1 from 2. So that we can have 10x minus the x to be equals to 3.3 bar minus 0.3 bar. So in this case, what am I going to have? 10x minus x, which is going to give me what? A 9x. 3.3 bar minus 0.3 bar. This is going to just be as good as what? 3.3 minus 0.3. 3 minus 3 is 0. 3 minus 0 is 3. So I'm going to end up having a 3 there. So we are now solving for x. The same x which was this, I'm now solving it here, so that it can become a fraction. So that divided by 9 divided by 9, and the value of x becomes a 3 over 9. This is the form of a over b. But every time I'm expressing in the form of a over b, try by all means to break it into lowest terms. Is there a number which can go into 3 and the 9 without leaving any remainder? Yes, this is basically 1 over 3, and this is my expression where a is equals to 1 and b is equals to 3. I am done. So 0.3333 in the form of a over b is basically 1 over 3, and you are done. You go to the second part. I believe this is a video you'll be pausing where you need to pause, and you continue where you need to continue. So I'm deleting the part so that you can now go to the second b part. So b says 0.13 bar. Now look at where the repeating value is. The repeating is 3. 1 is not repeating. So it means it will start repeating at 3. So here what I have is 3, 3, 3, 3, 3, 3, 3, 3, 3 continuous. So what do I do here? I say let x be equals to 0.13 bar. That's my first equation. And then the second task is to do what? To multiply this x by a certain value so that the repeating part can move to the left side. So my repeating is not 1, my repeating is 3. So for 3 to come and move to this side, how many times am I going to multiply this to come and move to the other side? So I'm supposed to make sure that my decimal point moves 1, 2 times. So the only way the decimal point can move 1, 2 times is multiplying the x by 100. So I'm multiplying the x by 100. Last, in the previous a, we multiplied by 10 because they wanted the point just move once. But here I want the point to move 2 times. 1, 2. So we're going to multiply the x by 100. So multiply x by 100 so that we can have, or before you, maybe you can take it step by step first. So since this is my x, so this is my x, I can start first of all by multiplying by 10 to move my point the other direction. So I'm going to say I'm going to have multiplied by 10, which is 10x will give me a what? The point is going to move once, giving me a 1.3 bar. So now here, remember we're trying to look for two expressions. When we multiply them, the decimal part should cancel out. So the decimal part, we want the decimal part to cancel out. So the first part is to make sure that after a point there is a repeating part, and before a point there is also a repeating part moving to the left. So in short, after a point there should be a repeating part. I need an expression where after a point I need the repeating part to be after a point. So here I had x to be equal to 0.1, but 1 was not repeating. The only part which was repeating was 3 bar. So that is why the first part, the first case, I need to first of all make sure my repeating part is after the point before I can make it move to the left direction, so that when I subtract, the two expressions should have the repeating part after the point. So I'm going to have the second equation to be 10x to be equals to 1.3 bar. So as you can see in the and this one will have ended up, we're going to end up multiplying this by 100 when for me to have the 3 to move to the other side. So in short, the first step is 10x giving me this value, which is my second equation. Then the third step is going to multiply this x by 100 for the 3 to go to the other side. So I'm going to have the 100x to be equals to 13.3 bar. This will be my third equation. We're okay? So we're ending up multiplying by 100 so that to have the repeating decimals shift to the left, and we shall subtract the two equations so that the repeating part cancels out. So why am I trying to form two equations which are new from the x? If I use the 0.13, the decimals will not cancel out here, because there will be no expression which is going to cancel out the 1 and the 3 in the decimals, because they are not the same. Let's say for example 10x, this is 1.3 and this is 0.13. If I subtract these two, the decimals will not cancel out. Once this will just basically be 0.13 minus 1.30. The decimals will not cancel out. So the only expressions you can cancel out the decimals are those expressions having the same repeating values after a point. So after a point I have a 333. After a point I have a 333. So I'm looking for two expressions which have the same repeating decimals, which I'm going to use to subtract, so that those repeating decimals can cancel out when subtracted. So I'm looking for two expressions when subtracted, those two decimal expressions can cancel out. So 1 and 2 will be the two wrong expressions to use. So if I multiply this by 10, I'm going to have this expression, but 10x minus x will not cancel out my decimal. The decimal will still be there. So let me check my 100x. 100x minus 10x, this decimal will basically be cancelled out. 3 minus a 3 to cancel out. I'll have a 0 as my decimal this side, but I will not have a 0 on which I used to these two expressions. So that is why we ended up having three equations here. So here, what am I going to end up with? I'm now going to subtract equation 2 from equation 3, so that we can have 100x minus 10x to be equals to 3.3 bar minus 1.3 bar. The same decimals after a point, so that when they subtract, they cancel out. 100x minus 10x, what do I remain with? 100 minus 10, that's 90. So I'm going to have a 90x to be equals to 13.3 bar minus 1.3 bar. So this is just more like 13.3 minus 1.3. The decimal 3 minus a 3 is 0. 3 minus 1 is 2. That I'm going to have a 12 being formed there. The decimal is 0. They've cancelled out. But if you used these two, the decimals would not have cancelled out. It would have been difficult to express in the form of a over b. So I'm looking for two expressions which have the same decimals after the point. That is why I multiplied by 10x first, then went ahead and multiplied by 100x. We're okay? Yeah. So this is what I'm having. Then so for x over 90 over 90, and the value of x becomes a 12 over 90. Then reduce to lowest terms. Reduced to lowest terms. 6 in there is 2. 6 in there, that's how much? 15 in lowest terms. And then you are done, where a is equals to 2 and b is equals to 15. Done deal. Go to the C part. We can now go to the C part, deleting the same part. So C is 6.156 bar. So how do I express that in the form of A over B? So identify the repeating part first. What is the repeating part here? The repeating part is 5, 6. 1 is not repeating. So it means by the end of it, for 5, 6 to move this side, obviously the last expression which I need to have will need to multiply this by how much? A 1000. So I'll make sure my point move 1, 2, 3. For a point to move 3 times, this expression should be multiplied by 1000, because the repeating part needs to move to the left. That's the concept. So, but take it step by step. First of all, let x be equals to 6.156. This is a bar as my first equation. Then multiplied by 10. 10x is going to move 1. It means I'm going to have what? 61.56 bar as my second equation. So the 10x has achieved me having a repeating decimal on my right direction. Here I just had 156. I only need the repeating decimal to come about. So the 56 is a repeating number. Then I can now make this 56 move to my left side. So the 56 to move to the left side, that is why we simply say that for this 56 to come and move to the left side, this whole x will be multiplied by 1000 for the 56 to move to the left, because the point to move 1, 2, 3. So to the x we are multiplying by a 1000. So this becomes 1000x is going to move the decimal point 1, 2, 3, having 6156 point. When the point reaches here, since 56 was repeating, there will still be another 56 being formed there. And this becomes my third equation. So use the two equations which have the same repeating decimals. So equation 2 and equation 3. So that we can say subtract equation 2 from equation 3. So equation 2 from equation 3, I'm going to have 1000x minus 10x to be equals to 6156.56 minus 61.56. Then we subtract 1000 minus 10. This is going to give me what? 990x to be equals to this minus that. The decimal will cancel out. Then when we subtract that, we should have something like 605. I think this is 95. Confirm. You can confirm. And then we are now solving for x. This is 990 over 990. This goes, and the value of x becomes 6095 over 990. Then you can reduce it to lowest terms. I'm sure there are some values which can be reduced to lowest terms there. I don't know if 5 can work out. I believe 5 can work out. 5 in there is 1, 5 in there is 2, 5 in there is 1, remainder 4, 5 in there is that. So it means if I use a 5 to break it down, I'm now going to end up with 1219 over 5 in there is 1, 5 in there is 9. So this will be 1, 9, 5 in there should be 8. Try to confirm. So I'm going to have something of that nature. So this is my x value, where a is equals to 129 and b is equals to 198. And you are done. So this is how basically we'll be solving rational rational numbers, expressing them in the form of a over b, expressing them in the form of o over b. So that's how basically everything is done. So as an exercise, I want you to submit D, submit E, submit F, submit G, H, and I. So what did we say? There are only 3 steps or 2 steps. Number 1, let the expression to be x. Number 2, make sure that you form 2 expressions. For example, in this case, since 5x was the one repeating and 1 was not repeating, I'm going to form the second expression where 5x should start after the 6 should start after the point. So 1 should go to the other side because 1 is not repeating. I only want the repeating decimals. So 1 can move to the other side. How can 1 move to the other side? By multiplying it by what? 10. So 1 point will move, the point will move 1 step, so that we multiply x by 10, then that's when the point can move 1 step to the right, so that I can have 61.56. So now we form the second equation, which is going to have 5, 6 again after the point. It means the 5, 6 need to move to the left side. So from the same x, how can I make this whole guy move to the left side when this x is multiplied by 1000? Then I'm going to have this by 1000, the point is going to move 1, 2, 3, hence having 6156 point. Since the point is here and 5, 6 was repeating, a 5, 6 again is going to be formed after the point. Then I have two expressions which have the same decimals repeating, 5, 6 and 5, 6. But in next case like D is basically 0.33, both 3, 3 are repeating. So automatically I just go direct and multiply this by what? 100. Then you just use the same x and the 100x to subtract, because after the decimal point the numbers 3, 3 are repeating. We still have the same decimals repeating. So this is your task. Submit it on our inbox and we'll basically comment. Thank you very much and have a blessed